Hello, all. Welcome to the day 25 of the daily case study series for CBSE Grade 12. The question goes like this: Ajay cut two circular pieces of cardboard and placed one upon the other as shown in the figure. One of the circle represents the equation x minus 1 the whole square plus y square is equal to 1, while other circle represents the equation x square plus y square is equal to 1. Based on the above information, answer the following questions. First subdivision: both the circular pieces of cardboard meet each other at. In this question, we have to give the point of intersection of the two circles. So let's take both the equations and solve them algebraically. The first equation given is x minus 1 the whole square plus y square is equal to 1. From here, we take y square is equal to 1 minus x minus 1 the whole square. Let's mark this as equation 1. Second equation is x square plus y square is equal to 1. From here, y square is equal to 1 minus x square. Let's mark this as equation 2. Comparing the equation 1 and equation 2, both the LHS are y square. That means both the RHS are equal. 1 minus x minus 1 the whole square is equal to 1 minus x square. 1 minus x square plus 1 minus 2x is equal to 1 minus x square. 1 minus x square minus 1 plus 2x is equal to 1 minus x square. 1 minus 1 becomes 0. Minus x square plus 2x is equal to 1 minus x square. The x square on the right hand side and the left hand side can be cancelled. 2x is equal to 1 and x equal to 1 by 2. The answer is option B. Second subdivision: graph of given two curves can be drawn as. The first equation is x minus 1 the whole square plus y square is equal to 1. Comparing this with the general form of the equation of circle, which is x minus h the whole square plus y minus k the whole square is equal to r square. Here h and k are 1 and 0. That is, the center is 1 comma 0. The second equation is x square plus y square is equal to 1. Rewriting this equation also in the standard form, x minus 0 the whole square plus y minus 0 the whole square is equal to 1, which means the center is 0 comma 0. On checking all the given options, C is a suitable answer. One circle is drawn with center 0 comma 0. That is the circle x square plus y square equal to 1. And the second circle x minus 1 the whole square plus y square is equal to 1 has the center 1 comma 0. So the answer is C. Subdivision 3. Integral 0 to half square root of 1 minus x minus 1 the whole square dx is. Now for this question, let's apply the formula x by 2 root a square minus x square plus a square by 2 sine inverse of x by a. Given question is integral 0 to 1 by 2 root of 1 minus x minus 1 the whole square dx, which is x minus 1 by 2 root of 1 minus x minus 1 the whole square plus a is 1. So it is 1 by 2 sine inverse of x minus 1 by 1, limits 0 to half. Applying the limits, upper limit half, so half minus 1 by 2 root of 1 minus half minus 1 the whole square plus half times sine inverse of half minus 1 minus, now applying the lower limit, 0 minus 1 by 2 root of 1 minus 0 minus 1 the whole square plus half times sine inverse of 0 minus 1, which gives us minus 1 by 4 root 1 minus half the whole square plus half times sine inverse of minus half minus half times square root of 1 minus 1 square plus half times sine inverse of minus 1, which gives us minus 1 by 4 root 1 minus 1 by 4 plus half times sine inverse of minus half becomes minus sine inverse of half minus the first term inside the bracket becomes 0 and we are left with half times sine inverse of minus 1 is minus sine inverse of 1, which gives us minus 1 by 4 into root 3 by 2 minus half times sine inverse of 1 by 2 is pi by 6, that is 30 degrees, plus half times sine inverse of 1 is pi by 2, which is minus root 3 by 8 minus pi by 12 plus pi by 4. On simplifying this, we get minus root 3 by 8 plus pi by 6, which is pi by 6 minus root 3 by 8. So the answer is option A. Subdivision 4. Value of integral half to 1 square root of 1 minus x square dx is integral half to 1 square root of 1 minus x square dx is equal to x by 2 root 1 minus x square plus 1 by 2 sine inverse of x by 1, limits half to 1. Applying the limits, we get 1 by 2 root 1 minus 1 square is 1 plus half times sine inverse 1 by 1 minus, applying the lower limit, half by 2 root 1 minus half square plus 1 by 2 sine inverse of half by 1. The first term becomes 0, and in the second term we have half times sine inverse of 1, which is pi by 2, minus 1 by 4 root 3 by 2. Again in the last term, 1 by 2 sine inverse of half is pi by 6, which is pi by 4 minus root 3 by 8 minus pi by 12. On simplifying this, we get 2 pi by 12 minus root 3 by 8, which is pi by 6 minus root 3 by 8. So the option is C. Subdivision 5. Area of hidden portion of lower circle. If we observe this portion very carefully, this area is formed because of the overlap of two equations. One is x minus 1 the whole square plus y square is equal to 1. From 0 to half comma 0, this part is formed because of this equation x minus 1 the whole square plus y square equal to 1. Then the next part from half to 1 has been contributed by the circle x square plus y square is equal to 1. We can get the area of the first and the second quadrant and then double it up to get the area of the entire shaded region. Required area is equal to twice integral 0 to half y dx plus integral half to 1 y dx. So from the diagram we understood that 0 to half area has been contributed by the equation x minus 1 the whole square plus y square is equal to 1. So from here we take y, which is root of 1 minus x minus 1 the whole square. So the first part changes like this: root 1 minus x minus 1 the whole square dx plus, and the portion from half to 1 is contributed by the equation x square plus y square is equal to 1. So from here we take y, which is 1 minus x square, integral half to 1 root of 1 minus x square dx. We need not do the integration of these two again because this was the one which was solved in the previous subdivisions. So we can take the answer from there: twice pi by 6 minus root 3 by 8 plus pi by 6 minus root 3 by 8, which is twice 2 pi by 6 minus 2 times root 3 by 8, which gives us 2 times pi by 3 minus root 3 by 4. That is 2 pi by 3 minus 2 root 3 by 4, which gives us 2 pi by 3 minus root 3 by 2. So the option is D. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.